We're back, baby! Live from the McNeil Studios in beautiful Baja Tustin. Professor Mark McNeil to talk about inflation.
What is this? McNeil Econ. Funny looking bird. Alright, well, actually we're talking about price level changes, and we are at the international headquarters in beautiful Baja Tustin. So we're going to talk about inflation, deflation, disinflation, and hyperinflation, and then nominal versus real, and how you measure inflation or price level changes. We can measure the change in the price of a particular good, but how do we measure the change in the price of all goods? That's the major issue here. So to start, prices change. Sometimes they're up, sometimes they're down. If there is a persistent increase in the average level of prices, this is inflation. It has to have all three of these components. It has to be persistent, not just a month or two. It's got to be extended. It has to be an increase, and the average level, not just a few things, not a third of the economy, but the general level of prices are going up. Deflation is the opposite. It's a persistent decrease in the average level of prices. Then there's a term, disinflation. Disinflation is a decrease in the rate of inflation. There's still inflation, but there's a decrease. So if, for instance, in 1978 or 9, the inflation rate was 12 or 14%. By the year 1992 or so, the inflation rate had gone down to about 2 or 3% per year. So there was still 3% inflation, but the rate had gone down. That's disinflation. Hyperinflation is extremely rapid increases in the price level. There are famous inflations. The most famous is the Weimar Republic one after World War I, where in a matter of maybe 2 or 3 years, what cost 1 mark, German mark, or Austrian mark, at the beginning of the period cost something like 1 billion marks at the end of the period. It was only two years or 3 years. And prices were rising so fast that the price of a restaurant meal changed as you ate it. Wives of factory workers would come to the factory gates, and the factory workers would be paid 2 or 3 times a day, and they would go take their money to their wives so that the wives could go and spend it before it lost all its value. That's hyperinflation. I've read that it's something over 300% per year, but the real big hyperinflations are even greater than that. Okay, we need to talk about the term nominal values versus real values. The nominal value of something is just whatever the dollar amount is that you pay for it or that you receive for doing something. The real value of something is adjusted for inflation. So that if, for instance, my pay goes up 20%, and at the same time the prices of everything go up 20%, then it means that my nominal income has gone up 20%, but my real income, that is the purchasing power that income will buy, has remained the same. So the nominal goes up 20%, but the real is the same, is unchanged, because prices all went up at the same time. What if your income goes up 20% and all prices go up 30%? Then in that case, there's been a negative change in your real income. Your real purchasing power of that income has gone down. Income went up 20%, prices went up 30%, so the real purchasing power, the real income has gone down. What is normally the case, or at least if inflation isn't too bad, is that your income goes up 20% and prices only go up like 15 or 18%, in which case your real income has gone up. The real purchasing power of your income is higher. So now the question is, how do we measure inflation? And the basic relationship is you take the nominal GDP, that's the current value of the goods purchased in current dollars, and you divide it by real GDP. And when you do that, you end up with the price level. And the price level times 100 is the price index. So it's like the percent equivalent of a decimal. It's like making a percent. You take the raw decimal and you multiply it by 100. So that's the difference between the price level and price index. All right, here's an example. First, nominal GDP is the sum of, that's my pathetic sigma sign, it's the sum of all of the goods sold, each one, the current price of the good times the current quantity, and you multiply price times quantity for every good in the economy, and you add it all up. And that gives you nominal GDP. That's the value of the goods and services produced in today's dollars. Real GDP is the sum of the goods base price times current quantity. So it's this year's quantity, but times the base price levels. I think I will explain it. Here's an example. Stay with it. I also have this online. I can put a link to it. So I have here an economy that only produces three things: bread, eggs, and since this is Irvine, Xanax. And then I have 4 years, 2001, 2002, 2003, 2004. So I've simplified it just because I want to get through it quickly. So if we take nominal GDP for each year, in year 2001, the quantity of bread was 10, and the price of each loaf of bread was $3, which, well, I'm told by Federico, the director here, that we had a little technical problem. I believe it's fixed now. We will see. If it is not fixed, at the International Film Students, we don't tolerate this kind of sloppy work, and heads will roll. That's all I can tell you, Federico. All right. I have constructed an example of how you calculate inflation. And we have to remember that it's nominal GDP divided by real. So I have the simplest economy you can draw, an economy where there are only three items produced: bread, eggs, and Xanax, because this is Irvine. And 4 years, 2001, 2, 3, and 4. So we're going to calculate nominal GDP, and we have to take each item, current price times current quantity. So in the case of bread, the current price is $3 and the current quantity is 10. So there were $30 worth of bread produced this year, in year one. Eggs, quantity is 25 and the price is 40, so 40 times 25 is $10. That's the nominal value of the eggs produced this year. And Xanax, 50 units of Xanax, $2 a piece, there's $100 worth of Xanax produced. And we add these three values: $30 for the bread, $10 for the eggs, and $100 for the Xanax. And so our nominal GDP in year one is $140. Year two, we had 8 units of bread times $4, that's 32 total. We had 22 eggs times 60 cents, and that's $13.20 total for the eggs. And 40 times $2.50 for the Xanax, that adds up to $100 again. Yes, $100. So nominal GDP is the sum of these three items. 32 plus $13.20 plus $100 is $145.20. That's nominal GDP in year two. Year three, 12 times 250 is 30. 28 times 30 is $8.40. 55 times 2 is 110, and the total nominal value is $148.40. Finally, in year four, bread 10 times $5 a loaf, so that's $50 total value of the bread produced. 25 times 50 cents for the eggs, that's $12.50. And finally, for Xanax, 50 times 250, that's $125. And when we add each of these up, we get the sum in nominal terms of GDP in this economy. It's $187.50. So if in fact GDP is trying to measure the value of output, in year one the GDP was 140, then it rose to 145, then it rose some more to 148, and then it rose a lot in year four. But what about the quantities? Between years 1 and 2, Bread went down from 10 to 8. Eggs went down from 25 to 22, the quantity of the goods produced. And Xanax, 50 versus 40. So in every category, there were fewer goods produced. And yet, our measure of GDP shows an increase. Then in year three, the quantities went up, up, and up. Year three's quantities are the highest, but look at the nominal GDP. It's only $148.40, which means, of course, that even though the quantities went up, the prices went down, and that's why we don't get a good reading of what's really happening to output. So how do we fix this problem? It turns out that it's fairly easy to fix this problem. Well, the problem is that prices change at the same time quantities change, and we're trying to measure quantity changes, and price changes screw that figure up. So what we do, the fix is to simply not let prices change. We have to pick a base year. It doesn't matter which base year we pick, but we have to pick one. So I picked year 2 just because it's not the first, and it's not the last, and it's not the highest, and it's not the lowest. I'm trying to make the point that you can pick any year. So year 2 is our base year, and now these will be the prices. We don't let prices change from year 2. So now we get real GDP by calculating the base year prices times the current year quantities. So what we're going to do is we're going to take in year 1 to calculate the real value of bread produced. We take year 1's quantity, 10, and we multiply it by not the current price, but the base year price. And year 2, the base year and the current price are the same, so it'll come out exactly as it is the first time. Then for year 3, we take year 3's quantities here, and we multiply it by $4, which is the base year price. So we get $48 worth of bread. For eggs, we take the quantity, 28, and we multiply it by the base year price, which is 60 cents, and that gives us $8.40 as the real value of the eggs produced. And for Xanax, there were 55 units of Xanax produced. We multiply by the base year price of $2.50, and that gives us $137.50. So we add, to get real GDP, we add each item's real values. So 48 plus 1680 plus 137.50 adds up to the real value of 202.30. So we do this for each year. And when we don't let prices change, the real GDP in the first year is 180, and then it goes up to to 145. And the quantities goes down, and the real GDP measure shows the decrease. Then in year 3, real GDP went from 145 to 202. And sure enough, that's accurate in terms of output, because output rose in each of these categories between years 2 and 3. So that's the real GDP for year 3. And then the real GDP for year 4, let me see. Am I going to count? I believe it's 180. Wait, it is 180. Why is it 180? Because I'm so dialed into this after so many years, I can just feel it. Like a Jedi Knight. Is that it? That's not it. There's a trick. Is the output the same in year 1 as it is in year 4? 10, 10, 25, 25. And if the real value in year 1 is 180, does the real value in year 4 have to be 180? Because the quantities are the same, and we're using the base year prices for each of them. That is the same price. So, does this accurately show what's happening to output in the economy? Absolutely. But we have to calculate it real. We can't let prices change. So what then is the price level? Well, to get the price level, you take the nominal value, in this case 140. So the price level for year 1 would be the nominal GDP in year 1 divided by real GDP in year 1, and that comes out to 0.78. If we want to convert the price level to a price index, we multiply it by 100, and we get 77.8, really. It turns out that when we divide nominal by real in the base year, it always comes out 1 and the index is always 100. So that's how you know what the base year is. The price level is 1 and the price index is 100. In year 3, nominal is 148 divided by real, 202, that's 0.73, or 73 is the price index level. And finally, in year 4, it's nominal of 187 divided by 180, that's 104. So that's how you calculate nominal and real and the price level. It's really just, if you can see it, it's really just a ratio of the prices between the current year and the base year. How much did prices go up between the base year and the current year as a ratio, as a proportion? So, I imagine you're very happy about this. This is the current data each year for the official data for the price index. This is an index, not a price level. And what this says is that the price level on January the 1st, 1960 was 17.27. What is our base year? The price level just keeps going up, up, up. Turns out the prices don't go down very much. But right here in 2010, the price index is 100. That tells you that 2010 is the base year because the price index is 100. Now, what is this index number here in January of 60? It says, if you buy a bunch of stuff, that stuff costs you $17.27. If you go back in the base year, which is 2010, and buy exactly the same stuff, that same stuff is now going to cost you $100. That's how much prices have increased between the base year, which is 2010, and 1960, which is this year. This is 2365. Whatever you could buy in the base year for $100 is going to cost you $23.65 in January 1st of 71. So that's what indexes tell you, how much something would cost you this year compared to another year after you've adjusted for the price changes. So what can you use it for? Well, you can figure out the inflation rate. That's nice. It's the percent change in the price level. Change, this idea of change, you calculate as change over base times 100. So if we're going to look for the inflation rate between 1998 and 1999, we take the price level that refers to 1999 and we subtract 1998's year. That'll give us the change in the price level, which is 1.8. And then we divide that by the base, that is the first year. And the first year's base is 79.1. So it's 1.8 divided by 79.1 times 100, and that gives you 2.275%, which is the inflation rate for that year. It's the change in the price level expressed as a percent change between 2 years. You can also use this to figure out the real cost of things. So for instance, in 1972, 1 dozen red roses cost $12.50. By the year 2017, those same roses cost $40. But prices changed. So the question is the real cost of roses in 1972, expressed in those dollars, higher or lower than $40 was in 2017? So, in which year were roses really more expensive? And how you figure that out is you take the $12.50 and divide it by 1972's price level. Not index, price level. And then you take the $40 and divide it by the price level for 2017. So I have conveniently done that for you. And what do you suppose, in which year was it more expensive? Well, you take $12.50 and divide it by the price level in 1972, which was 0.2602, and that comes out to 4804. This 4804 is the value of base year dollars. So we've converted this 72 price to 2010 dollars. Then 2017 it cost $40, but prices had changed, so we divided by the price level for 2017 to figure out, to kick it back into 2010 prices. So 40 divided by 1.1205 is $35.70. So in which year were the dozen roses more costly? And the answer is in 2017, because the real value of that money, the $40 that they spent in base year dollars, is 35.72, whereas the real value of $12.50 paid in 1972 in base year dollars is $48. So it was more costly in 1972. So you can figure stuff like that out. Are there problems with inflation? Yes, there are wealth shifts. Wealth goes from lenders to borrowers. Because when the borrower borrows money, they borrow money with real purchasing power. But then with inflation, when it comes time years later to pay the money back, the money has very much less purchasing power and is easier to earn. So when the lender receives the money back, they get less purchasing power because of the inflation. And that's a wealth shift from lenders to borrowers. Uncertainty. Would anybody lend money knowing that the amount they're going to get back later is less than in purchasing power than what they're lending now? They won't, unless they can know exactly what the inflation is going to be. But can anybody know what the inflation is going to be 10 or 20 years down the road? No. So what they do is they tend to not lend because of the uncertainty. The other thing is that inflation destroys the medium of exchange. In hyperinflation, they used to buy things with just packs of money. And it would take literally a shopping bag of money to buy a shopping bag of groceries. They didn't even count the bills, they just count the bundles. And all of a sudden, money just doesn't work the way it's supposed to anymore. And remember that prices are the central processing unit of an economic system. They tell everybody what to do and how to be efficient and how to deal with scarcity. Well, when prices are going crazy because of inflation, all of a sudden that price mechanism doesn't work and the economy tends to fall apart. So that's inflation. What do you think?
Exciting.
From beautiful Baja Tustin, out. Oh, wait.